Pipe welding and fabrication. Introduction to pipe welding and fabrication. Hello folks, welcome to this detailed lecture on pipe welding and fabrication. In this session, we will cover essential pipe welding techniques, safety practices, and explore advanced methods in welding for a comprehensive understanding suitable for employees working in this field. Pipe welding techniques and safety. Understanding pipe welding techniques. Pipe welding is a specialized skill that involves joining pipes by melting the metal at the joint with intense heat. The process requires precision and expertise to ensure strong, leak-proof joints, types of joints in pipe welding. Butt joint. This is the most common type where two pipes are aligned parallel end to end. Proper alignment is critical, and the joint usually requires a root pass followed by several fill passes. T-joint. Formed when a pipe is welded perpendicular to another pipe, creating a T-shape. This joint can be challenging as it involves welding in different positions. Socket weld. A pipe is inserted into a recessed area of a fitting and then welded in place. It's typically used for small diameter pipes. Lap joint, rarely used in pipe welding. This involves overlapping to ends or edges and welding them together. Safety practices in pipe welding. Ensuring safety in pipe welding is paramount. Ignoring safety regulations can lead to accidents, health hazards, and fatalities. Here are key safety practices: personal protective equipment (PPE). Helmets and shields protect the welder's face and eyes from sparks, spatter, and harmful radiation. Gloves, insulated and fire-resistant to protect hands from heat and electrical hazards. Protective clothing. Long-sleeve flame-resistant clothing helps prevent burns from sparks and arc radiation. Respirators, important in environments with questionable air quality to guard against inhalation of fumes and gases. Safety procedures. Ventilation. Ensure proper ventilation to minimize the risk of fume inhalation. Fire safety. Keep fire extinguishers nearby and remove any flammable materials from the working area. Electrical safety. Regularly inspect equipment for exposed wires or any electrical faults. Training. Employ regular safety training sessions to update workers on best practices and new safety protocols. Pipe fabrication and installation. Pipe fabrication involves cutting, bending, and assembling pipes according to specific drawings or blueprints. Successful installation ensures the system's efficiency and longevity. Key steps in pipe fabrication: cutting and preparation. Pipes must be clean, free of rust, and cut accurately using appropriate methods such as saw cutting or laser cutting based on the material and thickness. Bending. Pipes are bent using mechanical and hydraulic benders to suit design specifications. Precision is crucial to avoid leaks and pressure issues.
Pre-assembly. Parts are pre-assembled to inspect fit-ups before final welding, ensuring alignment and minimizing errors during final assembly. Installation techniques. Alignment and leveling. Ensuring pipes are properly aligned and leveled to prevent undue stress on the joints. Joint preparation. Clean and properly prepared joints for welding to ensure a strong bond. Testing. Hydrostatic and pneumatic testing ensure the integrity and strength of the installed pipelines. Advanced welding techniques for pipe welding. Advanced welding techniques can significantly enhance performance, efficiency, and safety in pipe welding projects. Automated and robotic welding. Automated systems reduces human error and increases precision, especially useful in repetitive or complex welds. Robotic welding. Applicable in large-scale operations where precision and speed are essential. High-frequency resistance welding. This technique uses high-frequency electrical currents to weld without the need for filler material, improving welding speed and efficiency. Hybrid laser arc welding. Combines laser beam welding with traditional arc welding, offering deeper penetration and faster welding speeds. Executive summary. Here's a summary of pipe welding and fabrication. Pipe welding overview. Pipe welding involves joining two or more pipes together using a welding process. The most common welding processes used for pipe welding are: 1. Shielded metal arc welding SMAW. 2. Gas metal arc welding GMAW. 3. Gas tungsten arc welding GTAW. 4. Flux cord arc welding FCAW pipe fabrication overview. Pipe fabrication involves creating custom pipe systems for various industries, including 1. Oil and gas. 2. Chemical processing. 3. Power generation. 4. Water treatment. Pipe welding techniques. 1. Rolling involves rotating the pipe to access the weld joint. 2. Positioning involves positioning the pipe to access the weld joint. 3. Clamping involves clamping the pipe in place to ensure accurate alignment. 4. Welding involves applying heat and filler metal to join the pipes. Pipe fabrication techniques. 1. Cutting involves cutting the pipe to the required length. 2. Bending involves bending the pipe to the required shape. 3. Forming involves forming the pipe into a specific shape. 4. Assembly involves assembling the pipe system. Safety considerations. 1. Personal protective equipment (PPE). Wear proper PPE, including a welding helmet, gloves, and safety glasses. 2. Ventilation. Ensure adequate ventilation to prevent inhalation of fumes and particles. 3. Fire safety. Keep the work area clean, remove flammable materials, and have a fire extinguisher nearby. 4. Electrical safety. Ensure proper electrical connections, avoid overloading, and use electrical insulation as necessary.
Best practices. 1. Regular maintenance. Regularly inspect and maintain equipment to prevent accidents and ensure optimal performance. 2. Proper training. Ensure proper training and certification before performing pipe welding and fabrication. 3. Follow safety protocols. Follow established safety protocols and guidelines to prevent accidents and ensure a safe working environment. 4. Use proper materials. Use proper materials, including pipes, fittings, and welding consumables, to ensure optimal performance and safety. Here's a summary of pipe welding techniques and safety considerations. Pipe welding techniques. 1. Rolling involves rotating the pipe to access the weld joint. 2. Positioning involves positioning the pipe to access the weld joint. 3. Clamping involves clamping the pipe in place to ensure accurate alignment. 4. Welding involves applying heat and filler metal to join the pipes. 5. Root pass, the first pass of the weld, which establishes the root of the joint. 6. Hot pass, the second pass of the weld, which fills the joint and establishes the weld's shape. 7. Fill pass, the third pass of the weld, which fills the joint and establishes the weld's size. 8. Cap pass, the final pass of the weld, which completes the joint and establishes the weld's surface. Safety considerations. 1. Personal protective equipment (PPE). Wear proper PPE, including a welding helmet, gloves, and safety glasses. 2. Ventilation. Ensure adequate ventilation to prevent inhalation of fumes and particles. 3. Fire safety. Keep the work area clean, remove flammable materials, and have a fire extinguisher nearby. 4. Electrical safety. Ensure proper electrical connections, avoid overloading, and use electrical insulation as necessary. 5. Slip, trip, and fall prevention. Ensure the work area is clear of obstacles and tripping hazards. 6. Proper lifting techniques. Use proper lifting techniques to prevent injury when handling heavy pipes and equipment. Best practices. 1. Regular maintenance. Regularly inspect and maintain equipment to prevent accidents and ensure optimal performance. 2. Proper training. Ensure proper training and certification before performing pipe welding. 3. Follow safety protocols. Follow established safety protocols and guidelines to prevent accidents and ensure a safe working environment. 4. Use proper materials. Use proper materials, including pipes, fittings, and welding consumables, to ensure optimal performance and safety. 5. Inspect welds. Regularly inspect welds for defects and imperfections to ensure quality and safety. Here's a summary of pipe fabrication and installation. Pipe fabrication. 1. Cutting. Cutting pipes to required lengths using various methods such as sawing, grinding, or using a pipe cutter. 2. Bending. bending pipes to required shapes using various methods such as hydraulic bending or induction bending. 3. Forming pipes into specific shapes using various methods such as rolling or pressing. 4. Assembling pipes and fittings together using various methods such as welding, threading, or grooving. 5. Inspecting fabricated pipes for defects and imperfections. Pipe installation. 1. Planning the installation route, taking into account obstacles, clearances, and access. 2. Excavating trenches or holes for underground pipe installation. 3. Pipe handling and transporting pipes to the installation site. 4. Installing pipes, fittings, and valves, ensuring proper alignment, leveling, and securing. 5. Testing installed pipes for leaks, pressure, and flow rate. Safety considerations. 1. Personal protective equipment (PPE). Wearing proper PPE, including hard hats, safety glasses, and gloves. 2. Fall protection, ensuring proper fall protection, such as harnesses and lanyards when working at heights. 3. Confined space entry, following proper procedures for confined space entry, including ventilation and rescue plans. 4. Heavy equipment operation, ensuring proper training and certification for heavy equipment operation. Best practices. 1. Regular maintenance. Regularly inspecting and maintaining equipment to prevent accidents and ensure optimal performance. 2. Proper training, ensuring proper training and certification for pipe fabrication and installation. 3. Follow safety protocols, following established safety protocols and guidelines to prevent accidents and ensure a safe working environment. 4. Use proper materials, using proper materials, including pipes, fittings, and welding consumables to ensure optimal performance and safety. 5. Inspect and test. Regularly inspecting and testing installed pipes to ensure quality and safety. Here's a summary of hybrid laser arc welding. What is hybrid laser arc welding? Hybrid laser arc welding (HLA) is a welding process that combines the benefits of laser welding and arc welding. This process uses a laser beam to create a keyhole in the workpiece, while an arc welding process, such as gas metal arc welding (GMAW) or gas tungsten arc welding (GTAW), is used to fill the keyhole. Advantages. 1. Increased welding speed. HLAW offers higher welding speeds compared to traditional arc welding processes. 2. Improved weld quality. The laser beam creates a precise and consistent keyhole, resulting in high-quality welds with minimal porosity. 3. Reduced distortion. The hybrid process reduces distortion and residual stresses, resulting in improved weld accuracy and reduced post-welding processing. 4. Increased penetration. The laser beam can achieve deeper penetration than traditional arc welding processes. Applications. 1. Automotive industry. HLAW is used in the automotive industry for welding high-strength steel and aluminum alloys. 2. Aerospace industry. HLAW is used in the aerospace industry for welding titanium and other high-strength alloys. 3. Heavy equipment manufacturing. HLAW is used in heavy equipment manufacturing for welding thick steel plates. 4. Shipbuilding. HLAW is used in shipbuilding for welding high-strength steel and aluminum alloys. Equipment and safety considerations. 1. Laser safety. Proper laser safety precautions must be taken to prevent eye damage and skin burns. 2. Arc welding safety. Proper arc welding safety precautions must be taken to prevent electrical shock, fire, and explosion. 3. Ventilation. Proper ventilation must be provided to prevent inhalation of fumes and particles. 4. Training and certification. Proper training and certification must be provided to operators to ensure safe and effective use of the HLAW process. Best practices. 1. Regular maintenance. Regularly inspect and maintain equipment to prevent accidents and ensure optimal performance. 2. Proper training. Ensure proper training and certification for HLAW operators. 3. Follow safety protocols. Follow established safety protocols and guidelines to prevent accidents and ensure a safe working environment. 4. Use proper materials. Use proper materials, including welding consumables and shielding gases, to ensure optimal performance and safety. Here's a summary of advanced welding techniques for pipe welding. Advanced welding techniques. 1. Orbital welding, a technique that uses a rotating welding head to weld pipes in a single pass, improving weld quality and reducing welding time. 2. Narrow groove welding, a technique that uses a narrow groove to reduce the amount of weld metal required, improving weld quality and reducing welding time. 3. Pulsed welding, a technique that uses a pulsing current to improve weld penetration and reduce heat input, improving weld quality and reducing distortion. 4. Hot wire GTAW, a technique that uses a hot wire to preheat the workpiece, improving weld penetration and reducing heat input. 5. Laser GTAW hybrid welding, a technique that combines laser welding with GTAW to improve weld quality and reduce welding time. Benefits of advanced welding techniques. 1. Improved weld quality. Advanced welding techniques can improve weld quality by reducing porosity, lack of fusion, and other defects. 2. Increased productivity. Advanced welding techniques can increase productivity by reducing welding time and improving weld quality. 3. Reduced distortion. Advanced welding techniques can reduce distortion by improving weld penetration and reducing heat input. 4. Improved safety. Advanced welding techniques can improve safety by reducing the risk of electrical shock, fire, and explosion. Challenges and limitations. 1. Equipment costs. Advanced welding equipment can be expensive, making it challenging for some companies to adopt these techniques. 2. Operator training. Advanced welding techniques require specialized training, which can be time-consuming and expensive. 3. Material limitations. Advanced welding techniques may not be suitable for all materials, and some materials may require specialized welding techniques. 4. Quality control. Advanced welding techniques require strict quality control measures to ensure that welds meet the required standards. Conclusion: mastering the techniques, safety standards, and advanced methods in pipe welding and fabrication is crucial for professionals in this industry. By adhering to the guidelines outlined, welders can ensure both the structural integrity of their projects and maintain a safe working environment. Continuous learning and adaptation to new technologies will lead to improved efficiency and effectiveness in pipe welding tasks. See you again in the next lesson. Happy learning, folks!